Welcome back. In this video, we are going to talk about DB buffer cache, which is one of the most important memory pools within SGA. So let's understand what is it. The database buffer cache is a critical component of the Oracle System Global Area or SGA. Think of it as the front desk of the database memory architecture. Whenever a user requests data, instead of rushing to the slow storage disks every time, the database first checks the DB buffer cache. It stores copies of frequently accessed data blocks in memory, making retrieval lightning fast. In short, it's the database way of keeping hot data close at hand. Inside buffer cache, there are also further segregation of pools, which we can quickly see in this below chart. Now here you can see that we have some different type of buffers like free buffers, pinned buffers, dirty buffers, hot buffers, and cold buffers. There could be other segregation as well, but let's try to understand what is shown here. So when we say free buffers, that means these are the empty slots in the cache. When we say pinned, that means those blocks are currently in use by a session. When we say dirty buffers, that means these are modified blocks not yet written to a disk. Hot buffers are the frequently accessed blocks, as well as cold buffers are very rarely accessed blocks which can be replaced by other useful blocks. Now let's understand why do we need it. Without the buffer cache, every query would hit the physical disk, which is significantly slower than memory. This would mean sluggish performance, frustrated users, and wasted resources. The buffer cache reduces I/O operations, speeds up transactions, and ensures scalability. It's also essential for concurrency, as multiple users can access cached blocks simultaneously without waiting for disk reads. In high availability or OLTP systems, when tuned properly, this cache helps us achieve near-time responsiveness. Now, how do we implement or configure it? In Oracle, the buffer cache is part of the SGA and its size is controlled by initialization parameters. For example, DB cache size defines how much memory is allocated to it. DBS can tune this parameter based on workload. Set it too small and you will see frequent disk reads. Set it too large and you may waste memory that could be better used somewhere else. As shown earlier, Oracle versions also support multiple buffer pools like keep and recycle, allowing fine-grained control over which objects stay cached longer or are cycled out quickly. This flexibility ensures that critical tables and indexes remain readily available, while less important data doesn't hog memory. So that's it for this video. Thank you.